Most BMW owners think they're using their car's advanced features correctly, but they're actually destroying thousands of dollars worth of technology without even knowing it. Last month, a guy brought me a 2021 X5 with just 32,000 miles on it, and the wiper motor was completely burned out. The linkage was bent, both blades were torn, and he was looking at a $1,400 repair bill. I asked him one question. Did you turn off your automatic rain-sensing wipers before going through the car wash? He said, I didn't even know you could turn them off. That one habit destroyed his wiper system in a single car wash visit. Here are 10 BMW features that owners consistently use wrong, causing expensive damage, and number 1 will cost you your entire engine if you keep doing it. Number 10, your rain-sensing automatic wipers have a hidden weakness that destroys the motor in a single car wash visit. Here's what's actually happening inside that optical sensor every time you leave it switched on. The automatic rain-sensing wiper system utilizes an optical rain light solar sensor mounted on the interior windshield within the rearview mirror cowl. The sensor emits infrared light onto the outer glass surface and measures the angle of refraction. When water droplets disturb the beam, the sensor module calculates the rainfall intensity and triggers the wiper motor. On rear wiper-equipped variants, shifting the transmission into reverse while the front wipers are running automatically triggers a wipe of the rear glass to ensure immediate rearward visibility. In automatic car washes, the moving brushes or high-pressure sprays trigger the optical sensor, causing the wipers to sweep. The car wash brushes then collide with the moving wiper arms, bending the linkage, tearing the blades, or burning out the wiper motor. In sub-zero temperatures, if the wiper blades are frozen to the glass, automatic activation strips the internal drive gears of the motor, snaps the mechanical linkage, or blows the high amperage circuit fuse. The automatic wiper mode must be deactivated manually, either by pressing the button on the end of the wiper stalk on older models, or by pushing the stalk down to the off position on newer models, extinguishing the green LED indicator before entering a car wash, or when parking the vehicle in sub-zero environments. Drivers should verify that windshield surfaces are fully defrosted and physically clear of ice before activating the automatic wipe function. The auto-reverse logic also risks stripping the rear wiper motor if the rear blade is frozen to the rear glass, making this a year-round awareness issue. Number 9 on our list is the central storage compartment tray, and dropping coins or metal objects onto it will destroy a $1,200 circuit board underneath. The central storage compartment houses an integrated inductive wireless charging pad, a digital key NFC transceiver pad, and an LTE signal coupling booster. The NFC pad authenticates the digital key stored on a smartphone or key card to allow engine starting, while the inductive charging tray replenishes the device's battery. This multifunctional tray is standard on G-chassis vehicles equipped with Comfort Access 2.0 and iDrive 7, 8, or 8.5, including the G23 series, G35 series, G05, X5, and electrified iChassis models such as the i4 and the flagship iX. Operating inductive charging with foreign metal objects present on the tray induces high-frequency eddy currents in the metal. This creates a severe thermal load that can melt the plastic tray, destroy the underlying NFC or charging circuit board, trigger thermal shutdown warnings on smartphones, and accelerate the chemical degradation of the phone's lithium-ion battery. When a device becomes excessively hot during driving, remove it from the tray and utilize a physical USB-C cable for charging. The central storage compartment tray must be kept entirely free of coins, keychains, and other metallic debris. Only phone cases certified as fully compatible with Qi inductive charging, lacking integrated metal sheets or heavy magnetic plates, should be used. Place your phone face up, centered directly in the cradle to ensure proper LTE signal coupling and NFC authentication for the digital key system. Before we get to the next one, if you want a more in-depth look into how your German car can last 100,000, 200,000, or even 300,000 miles, This ebook reveals the exact maintenance secrets and brand-specific strategies that every smart BMW owner should know. If you want to check it out, the link is down in the description below. At number 8, we have the ambient air fragrance dispenser, and using aftermarket essential oils will destroy your entire HVAC system. The ambient air package uses a micropump and ionization system within the glove box to disperse dry mist scents from dual cartridges into the climate control ducts. This works alongside digital HVAC vent controls where physical or touchscreen sliders adjust internal air flaps using electric servo motors. This specialized luxury feature is installed on select luxury models, including the older G35 series, G01X3, and current G05X5, G07X7, and G77 series. Though note that BMW has actually phased this system out on their newest redesigned platforms, like the new G65 series and 2026 G45X3. Aftermarket essential oils have different chemical compositions and viscosities compared to the dry mist formula designed for this system. These oils leak inside the glove box, clogging the micropump and gumming up the HVAC blending flaps. Dust particles bind to this sticky residue, locking the motorized blending doors in place and causing their plastic drive gears to shear, resulting in expensive dashboard disassembly to replace broken actuators. Only official, factory-sealed ambient air cartridges should be installed in the dispensing unit. Airflow adjustments must be executed exclusively through the central touchscreen or light touches on digital sliders, never applying physical force to the vent louvers. Forcing the digital vent slats strips the internal servo gears, necessitating high-labor dashboard disassembly to replace the broken actuators. Number 7 brings us to the panoramic sunroof drainage system, and using compressed air to clear blockages will flood your interior electronics with thousands in damage. The dual-panel panoramic sunroof uses a perimeter drainage channel to collect water that leaks past the primary rubber seals, funneling it down A-pillar and C-pillar drainage tubes to exit safely beneath the vehicle. This design is standard or optional on all modern X-Series SUVs and touring wagon variants. Parking beneath trees or in dusty environments with the sunroof open allows organic debris, leaves, and pine needles to enter the tracks and completely clog the internal drainage tubes. During heavy rain, water overflows the headliner and drains down the interior C-pillars directly into the lower electronic compartments. In vehicles like the X5, these cavities house highly sensitive components such as the Harman Kardon audio amplifier, telematic control unit, and the rear fuse distribution block. Direct water contact causes short circuits, corrosion of wiring looms, and permanent module failure leading to keyless entry failure, complete loss of sound, and vehicle starting issues. The sunroof tracks must be regularly vacuumed and wiped clear of organic material. Test the drainage yearly by pouring a small amount of clean water into the channel corners to ensure it flows freely beneath the chassis. Never use high-pressure compressed air, as it can expand the drain hoses and pop them entirely off their internal fittings. And instead, use a flexible nylon line, such as a 2.0mm trimmer line, to clear any blockages. At number 6, we have the keyless comfort access system, and where you store your key fob at home is silently draining your battery every single night. The Comfort Access keyless entry system uses capacitive touch sensors in the exterior door handles and multiple low-frequency antennae to authenticate the remote key fob, allowing vehicle unlocking and engine starting without physical key interaction. This system is broadly equipped on nearly all modern E-chassis, F-chassis, and G-chassis passenger vehicles, and SUVs. Drivers frequently store the remote key fob within 10 to 15 feet of the vehicle when parked at home, or allow conductive road dirt, salt, and moisture to build up on the capacitive door handles. If you own an older BMW, keeping the key fob in close proximity prevents the body domain controller and other electronic modules from entering their designated sleep modes. While newer BMW keys made after July 2019 have motion sensors that put the fob to sleep after 2 minutes of sitting still, Older E chassis, F chassis, and early G chassis keys will constantly pull the car, creating a continuous parasitic draw. The constant pulling loop creates a continuous parasitic draw, leading to rapid, unexplained battery discharge and premature degradation of the AGM battery. Conductive dirt or salt buildup on the capacitive handle sensors can create an internal short circuit, forcing the door handle to constantly attempt to unlock or wake the vehicle's electrical systems. Key fobs should be stored at least 20 feet away from the parked vehicle or inside a signal-blocking Faraday bag. The exterior door handles must be kept clean to prevent capacitive short circuits. In high traffic or tight parking environments, the proximity unlocking features can be temporarily disabled via the iDrive vehicle settings to prevent unintended activation and parasitic drain. Number 5 on our list is cold start operation, and hammering the throttle on a cold engine is destroying your turbocharger bearings every single morning. Modern control networks integrate driver profiles, safety assistance thresholds, and drive mode parameters that coordinate alternator charging output, engine warming cycles, and transmission shift schedules to protect the powertrain. This integration is crucial on all modern models, especially those with direct injection turbocharged engines, including the 2-liter 4-cylinder and 3-liter inline-6 power plants. Operating the engine under high load immediately after a cold start, while the engine oil is cold and thick, causes localized oil starvation, and wear at the highly precise clearance areas of direct injection engines and turbocharger bearings. Low-speed pre-ignition is significantly more common at low engine temperatures because thicker engine oil is more easily swept past the piston rings into the combustion chamber. Leaving assistance thresholds unconfigured can also lead to unpredictable electrical draw or aggressive safety system responses that strain the steering rack and electrical modules. Upon cold start, the engine should idle for 30 to 60 seconds to build oil pressure and establish circulation before driving. The vehicle must be driven gently under light load until the engine reaches its full operating temperature before applying heavy throttle or high RPMs. Setting up individual driver profiles in the iDrive menu ensures correct climate, seat, and steering heating configurations to prevent sudden, excessive current draw on a cold battery. This simple habit protects turbocharger bearings, piston rings, and direct injection components from the accelerated wear that results from cold start abuse. At number 4, we have the electronic oil level measurement system, and adding oil without running the measurement cycle first will destroy your engine from the inside out. Modern engines rely on a thermal oil level sensor mounted in the oil pan to measure oil level using dynamic heat dissipation rates, displaying the reading digitally in the iDrive menu. This system is standard on all modern engines, including the N20, N55, B48, B58, S55, and S58. Adding engine oil immediately without executing the correct dynamic measurement cycle leads to overfilling because the sensor does not update instantly. Adding excess oil causes the crankshaft counterweights to physically strike and whip the oil into aerated foam. Because aerated foam is highly compressible, the engine oil pump draws in air pockets, causing oil pressure to drop rapidly. This results in direct metal-on-metal contact at the rod and main bearings, leading to catastrophic engine wear or bearing failure, while the excess oil also overloads the PCV system and causes permanent damage to the catalytic converters. The vehicle must be parked on level ground, brought to full operating temperature, and have the digital measure oil level cycle run in iDrive at an elevated idle speed. If oil is required, it must be added in small increments of no more than 0.25 to 0.5 liters, and the dynamic measurement cycle must be repeated before adding more fluid. Never add oil blindly based on mileage alone, as this single mistake can turn a routine top-off into a catastrophic engine replacement. Number 3 brings us to the automatic transmission park gear and electronic parking brake, and the order in which you engage them on a hill determines whether your transmission survives. Shifting the electronic gear selector into park actuates an electronic solenoid, rotating a lock rod and forcing a heavy, hardened steel parking pal to wedge between the teeth of the transmission's parking gear. This mechanically locks the transmission output shaft to prevent the vehicle from rolling, and this mechanism is found on all models equipped with ZF, 6-speed, and 8-speed automatic transmissions. Parking on steep inclines by pressing park and immediately releasing the foot brake without engaging the electronic parking brake causes the vehicle to roll slightly, binding the entire static mass of the car directly onto the small steel parking pal. This places immense shear and tensile stress on the pal, its guide plate, and the mechatronic linkages. Shifting out of park subsequently requires excessive force from the mechatronic solenoids, causing a violent clunk and stretching the mechanical release linkages. Eventually, this habit causes a failure where the transmission remains permanently locked in park, with repair bills frequently exceeding $8,000 to $12,000. When parking on any incline, come to a complete stop, shift the transmission to neutral, engage the electronic parking brake, slowly release the foot brake pedal to let the actual brake pads hold the vehicle's weight, and only then shift the transmission into park. This sequence transfers the vehicle's weight onto the brake pads rather than the parking pal, protecting the transmission's most vulnerable mechanical component. This simple 5-second procedure can save you from one of the most expensive and entirely preventable transmission failures on the road. At number 2, we have the xDrive Intelligent All-Wheel Drive System, and mismatched tires are silently destroying your transfer case every single mile. The xDrive All-Wheel Drive System routes torque dynamically between the front and rear axles, utilizing an electronically controlled, wet multi-plate clutch pack inside the transfer case. The system relies on wheel speed sensors to constantly monitor and correct traction differences, and is installed on all passenger vehicles and SUVs equipped with xDrive. Replacing only 1 or 2 tires, running mismatched sizes or tread depths, or installing tires without the official star rating creates a constant rotational delta that the control module interprets as continuous wheel slip. According to official BMW TIS technical guidelines, the maximum allowable tread depth variation is 2 mm on the same axle, which is about 2.5 of an inch, and the variation between the front and rear axles must be within 3 mm, or about 3.8 of an inch. When mismatched tires exceed these limits, the transfer case actuator continuously slips the wet clutch pack to compensate, generating extreme thermal energy that glazes the clutch plates and strips the internal actuator gears. Transfer case replacement on xDrive models typically costs $4,000 to $7,000, making proper tire management one of the most financially important maintenance habits for all-wheel drive owners. All 4 tires must be replaced simultaneously if the tread depth difference between the worn and new tires exceeds the manufacturer's tolerance. Only tires carrying the official star rating should be used, as they are manufactured to strict circumference standards. Tire pressures should be checked monthly and matched to the door jamb specifications to prevent changing the rolling circumference and triggering the transfer case's continuous compensation cycle. And finally, at number 1, the most destructive mistake, using Steptronic manual shift mode to lug the engine at low RPM under heavy throttle will shatter your pistons and destroy your engine completely. The Steptronic transmission provides a manual mode that locks the transmission into a driver-selected gear ratio via the paddle shifters or manual shift gate, overriding the automatic upshift and downshift mapping of the transmission control module. This manual feature is present on all modern models powered by direct injection, turbocharged petrol engines, such as the N20, B48, and B58. Drivers operating in manual mode frequently lug the engine by cruising at low engine speeds in a high gear and applying deep or wide open throttle to accelerate rather than downshifting to raise engine speeds. Operating under high load and high boost at low engine speeds triggers low-speed pre-ignition, where the fuel-air mixture spontaneously ignites during the compression stroke before the spark plug fires. While normal peak combustion pressure is around 80 bar, an LSPI event spikes pressures instantly to over 160 bar, shattering piston rings, cracking piston ring lands, bending connecting rods, and damaging rod bearings. This leads to sudden loss of compression, severe cylinder wall scoring, and often a thrown rod that punches through the engine block, causing catastrophic engine failure, costing $15,000 to $25,000. Heavy throttle inputs must never be applied at low engine speeds in manual mode. Drivers should downshift to raise engine speed above 2,500 to 3,000 revolutions per minute before applying substantial throttle. Only API SP, API SN+, or BMW Long Life 17FE+. Approved oils should be used, as they use magnesium-based detergents rather than calcium-based detergents to prevent LSPI, and direct injection fuel injectors must be kept clean with high-quality PEA-based additives to avoid carbon deposits that act as pre-ignition hotspots. These 10 features represent some of the most sophisticated engineering in the automotive world, but they require proper understanding and technique to deliver their intended benefits. From the simple rain-sensing wipers that can be destroyed in a single car wash to the Steptronic manual mode that can shatter your pistons, every feature on this list demands respect and proper operating procedure. The key insight from this video is that BMW engineers designed these systems to work within very specific parameters, operate them correctly, and they will provide years of reliable, sophisticated performance. Operate them incorrectly, and you will discover just how expensive German engineering can be to repair. If you enjoyed this video, hit that like button, and if you like content like this, hit that subscribe button, and I will see you in the next one.